Hello friends, welcome to the Chemistry Nuggets. I am Akanksha and in this series of videos I am going to cover periodic classification. It's a very big chapter and very important too. So the first topic what I am going to pick today is atomic radius and ionic radius. So let's get started. The question which is most commonly asked in the exams from this topic is which of the following species will have the largest and the smallest size? And the given species are magnesium, magnesium 2 plus, aluminium and aluminium 3 plus. Now look at the given species. Here magnesium is having 12 electrons as we know. So magnesium 2 plus is an magnesium cation having 2 plus charge. It means it has 2 electrons less than the magnesium, that is 12 minus 2 is equal to 10 electrons. Magnesium ion has having 10 electrons. Same in the case of aluminium, we knew 13 electrons. So aluminium 3 plus will have again 10 minus 3, 10 electrons. Now let's see how to solve this problem. So to solve this type of problems, we need to consider 3 points. The first of all is this: atomic radii decreases along the period. What does it mean? Let me explain. They are telling that the radius, atomic radius, decrease along the period. It means from magnesium to aluminium. See, both are coming in the same period, but magnesium comes first as its number of electrons is 12. Then later aluminium will come with 13 electrons. So they are telling atomic radii decrease along the period. It means aluminium is smaller in size and magnesium will be larger in size. So we can say, according to the rule, magnesium will be larger than aluminium. Let me explain this. Why they are telling that like this? We need not to learn anything. Just have an explanation. If we draw an octet structure of magnesium, let's see what will happen. This is plus 12 charge in the center, that is nucleus, having positive charge equivalent to the number of electrons. Now this is the nucleus. Now this is the first shell having 2 electrons, then the second shell having 8 electrons. This is called the octet structure. We already learned in lower classes. So 8 and 2 and the rest 2 electrons will be in the third shell, we can say like this. Now same, let's draw the aluminium. First there is a nucleus having 13 plus charge, then we have the first shell having 2 electrons, then the second shell having 8 electrons, and then we have the third and the outermost shell having 3 electrons. See, 2, 8 and 3, 13. Here 2, 8 and 2, 12 electrons. Now see what is going on here. We drew the structure. Now everything is here. See, in this case, in case of magnesium, number of electrons 12 and number of protons which is in the center is 12. In this case, in case of aluminium, number of electrons is 13 and number of protons in the center is 13. So what's the big deal? See carefully. From center to the outermost shell. Here also from this center to the outermost shell. In both the conditions, the number of shells are 3. That is the distance from the nucleus to the outermost shell, that is called valence shell, is same. Yeah, we can say as it is seen clearly. So what is then going on in case of aluminium? We can see in case of aluminium what is going on. Distance is same, but the center which is positively charged having more positive charge comparative to the magnesium. This is why the force of attraction which is exerted by the nucleus to the outermost shell and pulling the shell towards inside is more over here in case of aluminium. So the force of attraction is more, so the size will be smaller and this size comparatively larger. Correct? Now wait. Come to the, I told you now we have 3 points to consider. Come to the second point. The second point says cations are smaller than the parent. Now we have, in this case we have two cations. First is magnesium 2 plus and the second is aluminium 3 plus. Both are cations. Now according to the given rule, cations are smaller than, sorry, let me, no, we will not discuss this thing here. The rule says cations are smaller than the parents. Now in this given case, this is the parent and this is the cation which is formed from the magnesium. So magnesium is a parent and parent atom and magnesium 2 plus is a cation. Now according to the rule, cations are smaller than the parents. It means parents will be the larger in size than the cation. Now how? Let me explain again. Again we will draw the octet structure. Very easy to draw. Nucleus which is 12 with plus charge. Then we have 2, 8. I think we don't have space to draw properly. Let's me check this. One more. Correct. Now see, 12 electrons, 12 protons in the center and 12 electrons moving around. In the case of magnesium 2 plus ion, the plus charge will be the same, because when the cations are formed or any ion is formed, only the electrons are moving. The number of electrons will be changed, but the number of protons will never change. So in this case the positive charge will be 12. Now come to the number of electrons. We have how many? 10 electrons. So as I told earlier, we have 10 electrons. See, this should be the structure. Now here E is electrons are 12, protons are 12. In this case electrons are 10 and protons are 12. Now we can see easily. Again we can see the distance. See, in case of magnesium atom there are 3 shells and in case of magnesium ion there are only 2 shells. So we can say the distance in the case of magnesium ion, the distance from the nucleus towards the outermost shell, that is the second shell, is less in comparison to the magnesium which is having 3 shells. So from nucleus to the third shell, the positive charge will exert force of attraction to the outermost shell, and when the distance is small and the positive charge is same, or we can say distance is small and the force of attraction will be more felt by the second shell in comparison to the third shell. So here the size will be smaller and this will be larger. Understand? Same in the case of aluminium and aluminium 3 plus. If we draw the octet structure, 2, because it has 13, so 2, 8 and 3. 1, 2, 3. And in case of aluminium, this 2 and 8 only, because 10 electrons. Same rule will be applied here. According to the rule, what they are telling, the parent will be the larger and the cation will be the smaller. So what we can say over here, this is the nucleus and it is exerting force of attraction to the second shell. In this case of aluminium, this is the nucleus and the distance is the third shell. So here distance is less and the number of electron 10, number of protons 13. See, number of electrons 13, number of protons 13. So distance is less, so the force of attraction which is felt by the second shell will be the more in comparison to the force of attraction felt by the third shell. So in this case, in case of aluminium 3 plus, the nucleus will pull the second shell with the more force of attraction and thus the size will be smaller. So this will be larger comparatively. See, now come to the third and the last point. What it says, among the isoelectronic, large cations have the small radii. Now what is isoelectronic? Now let me tell you, isoelectronic species are different ions or different atoms, mostly ions, which is having same number of electrons. Like in this case we have magnesium 2 plus and aluminium 3 plus. So why? Because magnesium having 12 electrons, so magnesium 2 plus having number of electrons 10. In this case number of electrons again 10, 13 minus 3, 10. So both are same, both number of electrons are same in both the cases, so these are called isoelectronic species. Now what the rule says for these things, large cation, this one having 3 plus, this is a large one. Large cation have a smaller radii, so it means the small will be the large. Small ion having the large radii, correct? Now again let me explain same with the help of octet structure. Now this is bit tricky. Why? This is nucleus having plus charge 2 and 8. See, correct? And in case of aluminium, central nucleus, then 2 electrons and then second shell 8 electrons, because both the cations having same number of electrons. Now as we know, E is equal to 10, but number of protons are 12 in this case, and in this case number of protons will be 13. Yes, because aluminium having 13 electrons, so protons will be the same. Now see, what will be the scene over here? Distance is same, second shell. Now if the distance from the nucleus towards the outermost shell, that is second shell in this case, in both the cases, so distance is same from the nucleus, but the force of attraction which is exerted by the positive charge is 12 in case of magnesium ion, and here it is 13 in case of aluminium. So here in case of aluminium ion, force of attraction is more. So the positive charge will attract the second shell electron with more power, more force of attraction. So the size of the aluminium 3 plus cation will be smaller, and this will be comparatively. So the simple funda is, larger the force of attraction, smaller will be the size. Got it? Now, so overall we can say that what we have, the question, and magnesium is the first number, largest, then aluminium, then magnesium 2 plus, and then, sorry, 1 minute. After that it will come aluminium 3 plus. So magnesium is the largest, largest size, and aluminium will be the smallest in size. Now, hope you guys understand the concept, and I hope this video will help you a lot for the topic given, that is radius, atomic radius and ionic radius. So if you guys like my video, and if you have any doubt regarding this video or any queries, you can simply post in the comment section. And if you want me to make videos on any specific topic related to chemistry, so please comment me in the comment box. Thank you.